video is to help out on being able to work the odd problems by me working the even problems. This lesson 3.4, is about slope. Slope is the rate that the output changes as the input changes. So for each individual step that the input takes, it's the rate that your output should be changing. On a graph, it's going to be the change in y divided by the change in x, which is what I have right here. And also could be thought of as the rise over the run. Either way, usually when we do these, the x value, the first one in the ordered pair, is the input. The second one in the ordered pair, the y value or f of x value, is your output. Okay? So using the definition, here we go. I'm going to work number 2. We've got 1, 6, and 7, 11. Slope is y2 minus y1 over x2 minus x1, which would be 5 over 6. So that is simple. Number 4. 2, 9, 6, 4. Slope is y2 minus y1 over x2 minus x1. It's negative 5 over 3. On number 6, 3, 7, negative 2, 11. Slope is y2 minus y1 over x2 minus x1. Number 8. You'll notice each time all I'm doing is I'm taking the second y value, subtracting the first one that gives me the change in y, and then I'm doing the same thing with the x's. So it's 6 minus 4 over negative 1 minus negative 3. 6 minus 4 is 2. Now right here where we have a minus negative, we need to make that addition, change the sign. Negative 1 plus 3 is 2. Slope here turns out to be 1. So for every time the x increases by 1, the y increases by 1. Okay. Looks like we're on number 10. Got 5 minus negative 1. Negative 6 minus 3 be 6 over negative 9. That'll be positive divided by negative is negative. 6 ninths reduces to 2/3. So every time the x increases, the y increases by going down 2/3. Okay, 4, 2, 4, 0. Slope is equal to y2 minus y1 over x2 minus x1. 0 minus 2 is negative 2. 4 minus 4 is 0. You can't divide an integer by 0, so this is going to be undefined. Later on, you'll find that when we have undefined slope, it's going to be a vertical line. And if you was to graph these two, 4, 2 would be right here. 4, 0 would be right here. The line that goes through them is a vertical line. Okay, so the slope is undefined. Okay. -2, -5, 3, -5. Slope is the change in the y, y2 minus y1, over the change in x, x2 minus x1, -5 plus 5 is 0, 3 plus 2 is 5, slope is 0. If you have a slope of 0, that means it's not increasing as the input increases. So if you have an axis and -2, -5 would have been over here. 3, -5 would be over here. And you'll see that as the x's change, the y staying the same. Slope is 0. Okay, I've got 2 more here. Slope is y2 minus y1 over x2 minus x1. End up with -3/5. So as the input changes, the output is dropping 3/5 for each change in input. Now I'll just do the other one on the same page here. I'll change colors. Points are 3, -2, -1, whoops. -6. Slope is the change in the y over the change in the x. -6 minus -2, I need to convert that to plus +2. Went up to -4 over -4. Negative divided by negative is positive. 4 over 4 is 1. So for each time the x increases by 1, the y is going to increase by 1. Okay, on these, they want to know if the slope slants upward or downward. On number 20, the slope is -3, so that would have a negative slope. So if I was in a graph, it would look something like this. It would be dropping 3 for every time the x changes 1. So it's pretty steep. So slants, whoops. Downward. We discussed number 22 earlier. If you have slope as being undefined, the graph is going to be a vertical line because the x isn't changing. So it kind of messes up our definition right here where it says slope is the rate of change in output per change in input. If the input's not changing, how can you measure slope? So on number 22, it's going to be vertical. On 24 through 28, I believe it asked which one had the high slope or the largest slope. L2 is the one that's positive, so the slope of L2, here I'll use this subscript there, slope of line 2 is greater than the slope of line 1. On 26, the slope of line 2 again is greater than the slope of line 1. Line 1 looks like it's horizontal, so it would have been 0. This one was positive. On this one, line 2 was positive, line 1 was negative. On this one here, it looks like line 1 is a greater positive because it's steeper than the slope of line 2. Okay. On this, you need to recognize that the formula for a linear equation equation in slope-intercept form is y equals mx plus b, or f of x is equal to mx plus b. So, number 29 is in slope-intercept form. F of x equals, this is my m, slope is going to be 5, it's not number 29. And the y-intercept is going to be -2. It's very useful and helpful when this thing's already solved for y or f of x, because you could just look at the slope and look at the y-intercept. Okay, number 30. Oh, I shouldn't have worked 29. It's a odd one. Number 30, the slope is -2, and the y-intercept is 6. On number 31 and on, they're not solved for y yet, so I will address that in the next video.